Okay, for this question, okay, this was a tricky one. You could do it as just starting dy dx is equal to 1 over the square root of x squared minus 1 over x squared plus 1, okay, because that's your log rule, okay, is 1 over the entire bit that follows the log, and then multiply it by the quotient rule. Well, actually, it'll be the chain rule and the quotient rule. Okay, so you could do it that way. It just works out really long if you do. Okay, so you would end up with taking a half multiplied by x squared minus 1 over x squared plus 1 to the power of minus a half, then multiplying it by the derivative of x squared minus 1 over x squared plus 1, okay, which would be the quotient rule. Okay, that's quite a long way of doing it. Okay, if you look at your rules of logs, okay, you have log e x squared minus 1 over x squared plus 1 to the power of minus a half. Take the half in front. Log e x squared minus 1 over x squared plus 1. Okay. Also, your rules of log take a half. Log e x squared minus 1 minus log e x squared plus 1. Okay, this makes it an awful lot easier. Okay, so a half times 1 over x squared minus 1 multiplied by the derivative of this, which is 2x, minus, so this isn't product rule here, there's a minus sign, so I'm just differentiating the two sides separately. Then to differentiate this, it's going to be 1 over x squared plus 1 multiplied by the derivative of this in here, okay, which is 2x. Okay, then that's a half times, multiply all the top line, so 1 by 2x is 2x over x squared minus 1 minus 2x over x squared plus 1. Okay, I need a common denominator here, so I get a half 2x by x squared plus 1 over x squared minus 1 minus 2x over x squared minus 1, okay, to get my common denominator. So to get the common denominator, I'd have to multiply the 2x by the x squared minus 1 and the x squared by the x squared minus 1. That gets me my common denominator. And the same for this side, I'd have to multiply by the x squared plus 1, x squared plus 1 to get me my common denominator. Okay, so make sure you absolutely know that step there. By the way, also at this point, I should have noted, you could have here also looked at saying a half log e to the x squared minus 1 minus a half log e to the x squared plus 1. Okay, you could have also applied the half on both of them rather than leaving it outside the bracket like I have. Okay, there's a couple of alternative ways of doing this question. Okay, so then you've got a half times 2x cubed plus 2x minus 2x cubed plus 2x over x squared minus 1 x squared plus 1. They cancel off. I'm left with 2x times a half. Okay. sorry, that should be, apologies, the top line should be 4x. Okay, a half cancels with the 4. That leaves me with 2 over x squared minus 1, x squared plus 1. Okay, this here is actually a difference of 2 squares. Okay, they're both squared terms. X to the power of 4 minus 1. Okay, so I'm sorry, that shouldn't have gotten rid of my x there. So that leaves me with 2x over x to the power of 4 minus 1. Okay, so make sure you know how to go through that, especially using the rules of logs. Okay, if you want to try it using this method also is fine. Okay, but here you've got to remember to use your chain, bring down your power, keep your base, and multiply by the derivative of this in here. Okay, so there's quite a lot if you're going to do this is option 1 or the more preferable option 2. Okay, moving into question 5. The first one asks you to differentiate y is equal to 2 ln x root x squared plus 1. So in here is a product. Okay, so again, you could use the product rule here. Okay, so option 1 would be to say you have 2 times 1 over x times root x squared plus 1 multiplied by the derivative of x root x squared plus 1, okay, which would actually be a product rule. So that's option 1. Again, that's quite long to do it that way. Option 2 is to say, well, that's 2 ln x plus 2 ln root x squared plus 1. Okay, so 2 times 1 over x plus 2 times 1 over root x squared plus 1 multiplied by the derivative of this, so x squared plus 1 to the power of a half. The derivative of this is I bring down my power, I keep the exact same base, bring the power down by minus 1, and then multiply by the derivative of in here, which is 2x. Okay, that entire thing there is the derivative of that. Okay, so really, really important that you remember your chain rule. Okay, that leaves me with 2x, or 2 over x, plus 2 over root x squared plus 1 times a half, 1 over the square root of x squared plus 1 times 2x, 2 over x plus 2 times 2 is 4x over 2, root x squared plus 1 times root x squared plus 1 is x squared plus 1. Okay, I've got 2 over x plus 2x over x squared plus 1. It asks for it all as one fraction, so I've got to do that. So my common denominator is going to be x and x squared plus 1. Okay, it doesn't require me to multiply out the bottom line. 4x squared plus 2 over x times x squared plus 1. Okay, it wants me to take out a factor. So take out my common factor of 2x squared plus 1 over x times x squared plus 1. Okay, so that's quite a long question to get to here. Okay, remember you can do it this way as well, but you're going to be using the product rule. So du is going to be equal to 1. dv in this case would be a half x squared plus 1 to the minus a half multiplied by 2x. And then applying your product rule, you should get the exact same answer. You will get the exact same answer as this. Okay? Going on from this, it then asks you to, and I'm just going to see, can I change my color pen? Okay, I can't. It then says find the equation of the tangent to the curve at x is equal to 1. So I'm just going to... Okay, I will put this, because I have some technical difficulties here. I will put find the tangent of the equation to the curve, okay, at the point y is equal to 2 ln x root x squared plus 1 at the point x is equal to 1. So I'm subbing 1 into this, to this equation here, okay, at x is equal to 1. I don't know why this is happening, okay. That will give me my slope. Okay, remember subbing into the derivative gives me the slope. So to find the slope at x is equal to 1, I'll sub in to this part here. That will give me the slope at x is equal to 1. And to find the y, I have to sub into the original here, okay, to get y.